My name is Jose Vela, and this is my diff screencast video 2, where we're going to talk about direction fields. So, we have to explain what is a direction field, the order, what those vertical points mean. We're going to have to draw. Then we graph it, and then we classify the stability of it. Then we find out what the infinity. We use limits, infinity, negative infinity, and then after that, we're just going to show use a little website to show. So to start off with, what is a direction field? A direction field is a way of graphically representing the solutions of a first order differential without actually solving the equation. By knowing the derivative, we can find the slope, and by finding the slope, we can find out where it's kind of going, like up, down. But to go more into depth with that, we got to know what the critical points are. A critical point is when the function is equal to 0 for the derivative, and then we're going to get, we can get a lot of points, but here we got 3, and then it's just going to show y equals 0, y equals 1, y equals 3. That's where the derivative is going to equal to 0. But then it also tells us whether there's a max or a min. So over here, I drew a little something. So basically, with the 3 critical points, y equals 0, y equals 1, and y equals 3, I drew a little line just showing that the derivative is equal to 0. So now, using the Desmos calculator, graphing calculator, we could find, there's a lot of slopes, but then over here, it's y equals 3, and that's equal to 0, y equals 1, and that's equal to 0, and then y equals 0 is equal to 0. But then, the derivative, the tangential line, hitting straight 0, 0, 0. Okay, next, we gotta find out, if it's stable or unstable. It looks better on this. Okay. So, the stability and unstable, if it's unstable, it's going away, and if it's stable, it's going in, going towards. So how I found this out was I FOILed the function we had originally, and I got y cubed minus 4y squared plus 3y. And then after that, I took the derivative, 3y squared minus 8y plus 3. And then I started plugging in our critical points. So my first critical point, y equals 0. And then I got 3. So 3 is greater than 0, and then that's unstable. And then I plugged in 1, and I got negative 2. Negative 2 is less than 0, so that is stable. And then the last one is y equals 3. I got 6, and 6 is greater than 0, so it's unstable. So how is that going to help us? Alright. It helps us right here. Because remember I said if it's unstable, it's going away. When it's stable, it's going in. So y equals 3 was unstable. It's going out. And then by finding that, I put the limits. So it's going to eventually go, it's unstable going to infinity. And right here, y equals 1, it's going towards, it's going in, so it's going to eventually hit infinity going in. And then finally, y equals 0, it was unstable, so it's going down towards negative infinity. So now finally we got to show the graph. This is my graph. Here we have the function. Then, like I've been saying a lot, y equals 3, it's 0, y equals 1, it's 0, y equals 0, it is 0. But over here it tells us a little something. It goes down towards negative infinity. I like that. I mean, eventually these will go, like what we showed, they'll go to infinity. But yeah, that's my assignment.